What is permutation and combination? This permutation, this is just an English word. This is English word for arrangement, rearrangement. Okay, like shuffling. So this permutation is like a shuffling, I can say, shuffle. Okay, and this combination, this is another word. This is an English word for selection. Means you are selecting some elements. So you can notice this permutation. If you check it out in the English dictionary, then this is just another word for order, arrangement. Okay, so this is the idea, arrangement or order. Means this is like a shuffle. You are shuffling some elements. Okay, so this is the idea. So you are rearranging the elements. So that is your permutation. Okay, for example, if I give you these three elements, A, B, C. Okay, then I can say that their permutation, this ABC is a permutation. This ACB, this is another permutation. So these are two different permutations because these are two different orders. Yes or no? These are two different permutations because in a permutation means order. So in a permutation, it will matter what is the order. So permutation basically simply means this is your order. So these two things are two different orders. Here B is coming before C, here C is coming before B. So these are two different orders. Now understand what is selection. So this is the idea of permutation. Permutation means order, or I can say arrangement. So the order will matter. Now just understand, let's assume that there are like, okay, there are many players. Okay, and let's assume, for example, there is Virat. Okay, maybe, okay, there is Rohit, and let's assume there is Pant. So okay, and you want to select two elements, select two players. So these are the players. What you want to select two players, select two players. This is what you want to do. You want to select two players for your Indian team, maybe. Okay, only two players you can select for the Indian team. Then how many ways are there? Then total how many ways? Only three ways are there. If you select two players, then tell me, you can select Virat Pant. Tell me, is it same? Are they same? Are they different or same? Are they different or same? They are same, right? They are same selection. They are same selection. Okay, so this is the idea because these are same selection. So these are the three players. You want to select two players, then you can notice these two are same selection. So order does not matter in a selection. In a selection, order does not matter. Yes or no? In a selection, order not matter. Order not matter. Okay, so I can say this is a selection. Another selection is Virat, Rohit. Another selection is Rohit, Pant. So only three selections are there. Yes or no? Agree? Only three selections you have. Now the same question, and if I ask you, if I ask you that you want to select two players for captain, vice captain, for captain, vice captain, for captain, vice captain. Now tell me, now are these two things same? Are these two things same? Now these are not same. Now these are different. Now these are not same. Because now you can notice, maybe, okay, this means Virat is the captain, Pant is the vice captain. Here Pant is the captain, Virat is the vice captain. So now they are not same. So you are selecting two players for captain, vice captain. Now order will matter. Okay, yes or no? Now order will matter. So now these two things are different. And can I say these two things are different, like Pant, Rohit? Yes, these are also different. Agree? So these are also different. Of course, these are also different. These two are also different. These two are also different. So for ABC, how many permutations you can create? How many different permutations you can create? Like this ABCA, BAC, CAB, CBA. So total 6 different permutations you can create. Permutation means arrangement. So I hope this idea is clear to everyone. Okay. So what I'm saying is, order matter or not? For tell me here, in which problem order will matter? In which problem order will matter? My fruit salad is a combination of apple, grapes, and bananas. Order matters or not? So order doesn't matter. Here order doesn't matter. Order doesn't matter here. In this problem, order doesn't matter. And what about this? The combination of safe is 472. Here matters. Here order matters. Okay, you should, because this is your password. So in a password, order matters. or in a set, order doesn't matter. Order doesn't matter. So in a set, order doesn't matter. Order of elements doesn't matter. And what about in a team, committee, group? There also order doesn't matter. Yes or no? So you can notice sometimes in life it is important that order matters. Like for example, sometimes in life order will matter. For example, English words. In an English word, order will matter. Ram and arm, these are different. So order will matter. Order of elements will matter. Okay. For example, string, sequence. These are the examples of where order will matter. In which order you are putting the elements, that will matter. Like first element, second element, third element. So this order will matter. Who is the first element? Who is the second element? Who is the third element? Next, sometimes order does not matter. For example, a set. In a set, order does not matter. If you are selecting a team, order does not matter. If you are doing a meeting, order does not matter. If you are doing selection, order does not matter. Okay. So tell me now. Remember, permutation means order matters. Another name of permutation is arrangement. Ordered arrangement. So this permutation is basically ordered arrangement. This is your arrangement, or by default order arrangement. And what is combination? This combination is just a word for selection, where order does not matter. So you can notice, for example, if you want to arrange people, so basically if you want to do this arrangement of people, digits, number, so this is your permutation. This is the example of permutation, because you are doing the permutation, you are arranging them. Okay, like picking a team captain, right? So here order will matter, yes or no? Captain, vice captain, and bowler, whatever. Okay, so this is the idea. Similarly, picking two favorite colors, like you are picking your two favorite colors in order. Like first you will pick your most favorite, and then you will pick your second favorite. So here also order will matter. What is your most favorite and what is your second favorite? But here order does not matter, yes or no? Picking two colors, here order does not matter. Picking two team members, order does not matter. Selection of menu, food, clothes, the order does not matter. If you want first winner, second winner, third winner, order will matter. But if you want top three winners, then order does not matter. Is this clear to everyone? When order matters, when order does not matter? Tell me, is this point clear? So you can notice permutation. Simply in the permutation, what happens? In a permutation, what matters? In a permutation, it matters what is the order and what are the elements. Two things will matter in a permutation. Remember, in a permutation, two things matter. For example, if I give you these A, B, C, D, if I give you these, now you can notice that in a permutation, what will happen? In a permutation, for example, let's assume I want to permute two of them. Okay, from this I want to permute two of them. Then can I say they are same? Can I say they are same? They are different. They are different permutations. And can I say they are same? They are also different. So these two are also different. So you can notice in a permutation, what are the elements and what is their order? These two things will matter. So what are the elements? Like here A, B are the elements. So their order will matter. Here B, A, here B, C. So they are different elements. So these two things will matter in permutation. In permutation, what are the elements? What is their order? And in combination, what matters? In combination means selection. Basically, you just want to select. In a selection, what matters? Only elements matter. What are the elements? That will matter. For example, this AB, AC. These are different selections, right? Yes or no? These are different selections. But these are not different selections. These are same. These are same. Correct? Is this point clear to everyone? So in a combination selection, what matters? Elements matter. Which are the elements? Their order does not matter. In a permutation, elements matter, their order also matters. So these are the two things: permutation, combination. These are English words, nothing else. These are just English words. Permutation means you are permuting them, you are shuffling them, okay, you are arranging them. So the order matters. And selection means you are selecting. Like there is a class, in that class there are 10 students, you want to select 2 students. Okay, so you can select two students like, okay, so Raj come here, like Ravi come here. So Raj, Ravi, two you are selecting. So basically in a selection, order does not matter. It will matter which two elements you are selecting. Like here, A, B we are selecting, here A, C we are selecting. But here, both are same. These selections are same. So this is the idea. Selection, combination, both are same. And permutation, arrangement, both are same. So this is the idea. Some examples of permutation. What are the examples of permutation? Like string, sequence, ordered pairs, ordered tuples, ordered triples. These are the examples of, in all these things, in an order pair, order will matter. And combination example is set, committee, team, group, something like this. Okay, so this is the idea. Now let's solve. So now first we will see what is a permutation. You can read what is a permutation. Permutation is nothing but a fancy application of product rule. This is nothing but product rule. If you know product rule, you also know this. Okay, so basically permutation P means permutation, arrangement, order, sequence, substring, all these things are same. And this is just your product rule, nothing else. Let's see the question. If you have these three elements, how many permutations are there with these three elements? So there will be total 6 permutations, 6 arrangements, ABC, ACB, and so on. Okay, now let's solve this question. What will be the answer? For this question, what will be the answer? The number of permutation, ordering, arrangement of 4 distinct elements. Your product rule, this is just product rule. You want to arrange 4 elements. Remember, you want to arrange 4 elements. So how many arrangements are there? Total 4 different elements you have. So for the first position, 4 choices. For the second position, 3 choices. For the second, okay, so like this. So what will be the answer? The answer is 4 factorial. This is your product rule. Did you notice? Permutation is nothing but product rule. So how many arrangements are there? You want to arrange 4 elements. There are 4 elements like A, B, C, D. These are the 4 elements. You want to arrange them. Then what you can do? For the first position, anyone can come. Anyone can come for the first position. Now, for the second position, the remaining 3, any of the remaining 3 can come for the second position. And then third position, then fourth position. So this is order. So finally, 4 factorial permutation you can create. What is the answer for this? 5 distinct elements. How many permutations of 5 distinct elements? So you have total 5 distinct elements. So for first position, 5 choices. For second position, 4 choices. For this, 3 choices. For this, 2 choices. For this, 1 choices. So the answer will be what? Product rule. This is just product rule. 5 factorial. What about this? If you have n distinct elements, how many orderings of n distinct elements? So you have n distinct elements. How many orderings will be there? Total n distinct elements you have. For the first position, you want to, there are n elements, there are n people. You want to order them in a line. You want to, okay, you want to put them in a line in a order. Okay, so orderings we are asking. So for the first position, any n people can come. For this n minus 1 and so on. For this n 1. So finally, if you multiply like this, then you will get n factorial. What will you get? You will get n factorial. So if you have n people, then how many orderings you can create? That is n factorial. With n people, there are n factorial orderings. For example, A, B, C, D, E, F. How many orderings are possible? This is my question. How many orderings are possible? Orderings are possible such that so tell me how many orderings will be there? F must be in the second position, E must be in the fourth position. So how many orderings, how many templates we have? So what will be the answer? Remember, F comma E are fixed. The remaining 4 people can arrange, yes or no? F comma E are fixed. F is here, E is here. The remaining 4 people, how many orderings? For the remaining 4 people, how many orderings? 4 factorial. For remaining 4 people, how many orderings? 4 factorial, yes or no? Because from the remaining people, anyone can come here. Then 3 choice here. then 2 choice here, then 1 choice here. So the answer will be what? That is your 4 factorial of 24. So this template, for this template, 24 strings we have. So because F comma E, they are already fixed. F position, E position, that is already fixed. The remaining 4 people, they can arrange in 4 factorial ways. Let's solve this question. How many orderings of 2 elements from 5 elements? How many orderings of 2 elements from 5 elements? What is that? You only want ordering of 2 elements. This is what you want. We want ordering of 2 elements. We only want 2 elements, remember. We only want 2 elements. And total we have 5 elements, A, B, C, D, E. These 5 elements we have, but we want 2 elements. Then for the first position, how many choices? How many choices for the first position? Any 5 can come. Any of them can come. And for this, 4. So the answer will be 20. Simple product rule. Simple product rule. Can you notice this is same as 5p2? Can you notice what is 5p2? Just find out what is 5p2. What is 5p2? Tell me. 5p2 is also 20. Is this a coincidence? Is this a coincidence like 5p2? Okay, just wait. Okay, so the answer is 20 by the product rule. Now let's move on. And what is the answer for this? Tell me. So you notice this point. If you notice NPR, what is that? NPR is basically n factorial divided by n minus r factorial. Okay, let's solve it. If you open it, then what will you get? If you open it, n minus 1, n minus 2, and so on, what will you get? Tell me. Till n minus r factorial, you open it. Till n minus r factorial. So what will be this value? This value will be plus this. This value will be plus 1. Like this value is plus 1. So this value will be plus 1. N minus r plus 1. Now what you can do? You can cancel this and this. So what is your NPR? NPR is simply n multiplied by n minus 1 multiplied by n minus 2 till n minus r plus 1. Till n minus r plus 1. Is this clear? This is your NPR. For example, remember this NPR is nothing but from n you start, go downwards till n minus r plus 1, only till this. How many terms are there? Number of terms. Tell me number of terms. How many terms we have here? How many terms we have here? Tell me. Here I can say minus 0. And here I can say minus r minus 1. So from 0 to r minus 1, these are r terms. You can just check it out. Very simple. These are total r terms. Because this is from n minus 0. You can just check. Okay, so we have total r terms here. So for example, if I ask you 7c4, then what you need to do? You go down only 4 terms. You go down only 4 terms. So 7, 6, 5, 4. Is this clear to everyone? This will be your answer. If I ask you, what is a 7c2? Then what you need to do? Go down only 2 terms. Go down only 2 terms. Okay, so go down only 2 terms. Apply this. So sorry, P. Okay, sorry for that, P. I'm talking about P. So 7p4, that will be just go down. Okay, for example, if I have 10p3, if I have 10p3, then what I need to do? Tell me what I need to do. 10, 9, 8, only 3 terms, because number of terms is r. So only 3 terms. So this will be your answer, 10p3. So from now onwards, you find like this. Is this clear? Always find like this, because remember your NPR. Always remember this. NPR is nothing but from n you start, go down. From n you start, go down, and only go till r terms. Only go till r terms. So the rth term will be n minus r plus 1. This will be your last term. Anything you can find now. For example, if I ask you 20p4, then that will be 20 multiplied by 19 multiplied by 18 multiplied by 7. 4 terms. This will be your answer. Okay, now let's see this question. So what will be the answer? How many orderings of R elements? How many orderings of R elements from a set of n elements? So total n elements you have, but we want only R elements. We want ordering of R elements. This is what we want. Okay, we only want the ordering of R elements. So for the how many permutations are there? How many orderings are there? So for the first position, how many choices? For the first position, how many choices? Total n choices. For the second, how many choices? N minus 1 choices. For the rth, how many choices? For the rth, how many choices? For the second, n minus 1. For the first, n minus 0, I can say. Okay, for the third, n minus 2. For the third, n minus 2. So for the rth, what will happen? N minus r plus 1. It will be n minus r plus 1. Because for this, what will happen? N minus r minus 1. And that is nothing but n minus r plus 1. Because remember, for the third, for this 3, we are doing n minus 2. For this 2, we are doing n minus 1. So for this r, we will do n minus r minus 1. N minus r minus 1. And that is nothing but n minus r plus 1. Now, just multiply them. So what is your answer? Can anyone tell me? What is your answer? What is this value? From n to n minus r plus 1. That is your NPR. So this is not a coincidence. This is your NPR. This is the proof. This is the proof that if you have n distinct elements, if you have n distinct elements, if you have n distinct elements, so total n distinct elements you have, from these n distinct elements, you want to permute. You want to permute R distinct elements. Means from these you want to permute R elements. Okay. So from these n elements, you want to permute from these. From these n elements, you want to permute R elements. So R is less than equal to n. Then how many ways? Permute. So how many number of ways? What is that? Number of ways. That will be NPR. And what is the proof? What is the proof? The proof is this. The proof is by the product rule. Can you notice this permutation is just a fancy word for product rule? Can you notice? Can anyone tell me that permutation is nothing but your product rule? The product rule, another name is permutation, or I can say permutation is application of product rule. This is your proof. This is the proof that the answer is NPR. Is the proof clear to everyone? So very simple. So this meme you can just check. Product rule permutation. So remember, permutation is nothing. This is nothing. This is just a fancy application of product rule, nothing else. The proof you have seen. So okay, understand the proof. This proof is very simple. So just apply the product rule, answer you will get. Okay, let's move on. So this is called R permutation. From n elements, you are permuting R elements. You are permuting R elements. This is called R permutation. This thing is called R permutation. Okay. So remember, from n things, you are taking R things. That is known as R permutation. That is called R permutation. And how many ways are there? Answer will be NPR. This will be the number of ways. Let's solve this question. Tell me what is the answer. Tell me what is the answer for this. In how many ways we can select 3 students? So we want to select 3 students from a group of 5 students to stand in a line for a picture. To stand in a line for a picture. To stand in a line for a picture. Order matters or not? Order matters or not? Yes, here order will matter. In a photo, order will matter. Like for example, in this photo, B is in the middle. In this photo, A is in the middle. So yes, they are different. They are different photos. So they are different photos. Okay, so finally, what is the answer? So basically 3 people you want from 5. So from 5 people, you want to permute, you want to order, you want to permute 3 people. So how many ways are there? 5p3. And what is that? 5 multiplied by 4 multiplied by 3, 3 times. So this is your answer. Answer will be 60. Okay, you can apply the product rule also. Just apply the product rule. 3 people you want. For the first 5 choices. For the second 4 choices. For the third 3 choices. This is your answer. And what for this? In how many ways? All the 5 people. For this, what will happen? All the 5 people. For this answer will be 5 factorial. Okay. So don't forget about this meme. Never forget about this meme. Permutation is nothing but your product rule. If you understand product rule, you already understand permutation. And what is the answer for this? How many ways are there to select a first prize, second prize, third prize from 100 people? So from 100 people, you want to permute, from 100 people, you want to permute 3 people. From 100 people, you want to permute 3 people. You want to permute 3 people. So what that will be? That will be 100 multiplied by 99 multiplied by 98. 3 terms. 3 terms. Only 3 terms. Okay, so this is very important. Again, I am telling you, when you write INPR, then what you do? To find this value, just directly do this. N minus 1, n minus 2. Go down, go down, go down. How many terms? Go down, go down, go down. How many terms? R terms. Go down, R terms, and the last term will be this. So basically R terms. So the answer will be this. And the same question you can solve using product rule. For the first prize, this is your first prize. For the second prize, 99. And for the third prize, 98. This is your answer from the product rule. Another question. So tell me what is the answer? You have 8 runners in a race. There is a race in which you have total 8 runners. Total 8 runners. And the winner will get gold medal. The second will get silver medal. The third will get bronze medal. How many ways they can finish if all possible outcomes and there are no ties? This is important. There are no ties. So the answer is very simple. 8p3. This will be your answer. So 8 into 7 into 6. 3 terms. That will be the answer. So very simple. This is just product rule. Nothing else. And this is your saleswoman. Has to visit 8 different cities. She must begin her trip in a specified city. But she can visit other 7 cities in any order she wants. So how many possibilities? How many possibilities? So the answer will be 7 factorial. Because already there is a specific city. So she will start in a specific city. Okay. So the first city is already decided by her. She has already decided the first city. The remaining 7 cities she can visit in 7 factorial ways.